In this video, you're going to learn how to conduct a one-sample mean z-test. One-sample mean z-tests were mentioned back in Lesson 5 when we covered one-sample mean t-tests, but we didn't actually do any of them then. I will give you a brief overview of when to use a one-sample mean z-test. I'll show you how to use the 5-step hypothesis testing procedure to conduct the test, and I'll walk through one example. What you're wondering now may be when. When do we use a one-sample mean z-test? Like the one-sample mean t-test, we use the one-sample mean z-test when we have data for one group, when the response variable is quantitative, and when we have a hypothesized population parameter. What is different with the z-test compared to the t-test is that we need to know that the population is normally distributed, and the population standard deviation, denoted by sigma, must be known. We are going to use the 5-step hypothesis testing procedure to conduct a one-sample mean z-test. The first step is to check assumptions and write hypotheses. The assumptions, which we've already seen, are that the population is normal, and sigma, which is the population standard deviation, is known. Once these are checked, we can write our hypotheses. These will be written in terms of the population mean, mu. The null hypothesis is always going to be that mu is equal to the hypothesized value. Here, we'll call that hypothesized value mu sub 0, but that mu sub 0 will be replaced by hypothesized population mean that you'll get from your research question. The alternative hypothesis will be that mu is not equal to, is greater than, or is less than mu sub 0, depending on if we have a two-tailed, right-tailed, or left-tailed research question. Step 2 is to compute the test statistic. The z-test statistic is equal to the sample mean minus the hypothesized population mean, divided by the standard error, which is equal to the population standard deviation over the square root of the sample size. In step 3, we look up the p-value. To do this, we construct a z-distribution. Recall that this is a normal distribution with a mean of 0 and standard deviation of 1. The p-value will be the area under the z-distribution that is more extreme than the test statistic observed in step 2 in the direction of the alternative hypothesis. And we'll walk through one example of this shortly. In step 4, we make a decision. If the p-value is less than or equal to the alpha level, which is typically 0.05, we reject the null hypothesis. If the p-value is greater than the alpha level, we fail to reject the null hypothesis. And finally, step 5, we state a conclusion. Based on your decision in step 4, write a conclusion in terms of the original research question. Let's walk through one example. Here's our scenario. In the population, IQ scores are normally distributed with a mean of 100 and standard deviation of 15. A college admissions counselor wants to know if the mean IQ of students at her college is different from the national average of 100. She collects data from a sample of 25 students and finds that they have a mean IQ of 108. From this scenario, we know that the hypothesized population mean is 100 because the counselor wants to know if the mean at her college is different from this value. The population standard deviation, sigma, is 15. The sample size is 25. And the observed sample mean is 108. We'll use the 5-step hypothesis testing procedure to address this counselor's research question. Step 1 is where we check assumptions and state hypotheses. The first assumption is that the population is normal. In this scenario, we learned that IQ scores are normally distributed in the population, so this assumption is met. The second assumption is that sigma, the population standard deviation, is known. We are given that the population standard deviation is 15. We have sigma, so this assumption is met. Now we can write our hypotheses. The research question is in the second sentence. The counselor wants to know if the mean IQ of students at her college is different from 100. The null hypothesis is that mu is equal to 100. She wants to know if the mean is different from 100, so the alternative is that mu is not equal to 100. Step 2 is to compute the test statistic. Here we have the formula for a z-test statistic. The scenario gave us all of these values, we just need to plug them in. Our observed sample mean of 108 minus the hypothesized population mean of 100 divided by the standard error, which is the population standard deviation of 15 divided by the square root of the sample size, 25. This gives us 8 over 15 divided by 5, 8 over 3. It's 2.667. This is our z-test statistic. In step 3, we determine the p-value by constructing a z-distribution and finding the area more extreme than the test statistic that we just computed in the direction of the alternative hypothesis. Recall that we just computed a z-test statistic of 2.667, and our alternative hypothesis was two-tailed. If we draw a z-distribution and find the area more extreme than 2.667, the p-value will be the total area in the left and right tails. You can find this area using StatKey or Minitab Express. 0.0038 plus 0.0038 gives us a p-value of 0.0076. In step 4, we make a decision. Our p-value is small. It is less than the standard 0.05 alpha level. Therefore, we reject the null hypothesis. In step 5, we state our conclusion going back to the original research question. We rejected the null, so there is evidence that the mean IQ score of all students at this college is greater than 100.